So today what we're talking about is solving inequalities. Now, these are going to be multi-step inequalities. And actually, we're going to be doing both equations and inequalities at the same time. So we'll put n equations in here. So we're going to look at a bunch of different equations and see how they work. And I'm just going to go through a few of these with you, and then we'll talk some more tomorrow about them. But let's say, for instance, I gave you 12m plus 12 equals 6 times 3m plus 3. Here, as always, and I think this is a good rule of thumb, is always get rid of the parentheses first. So always distribute through the parentheses. If you do that, you get 12m plus 12 equals 18m plus 18. Well, now, when I solve this, I'm going to subtract 12m from both sides, which will give you 12 equals 6m plus 18. I'll subtract 18 from both sides. I'll get negative 6 equals 6m divided by 6. So m is equal to negative 1. Pretty straightforward and simple when you think about it. Sometimes I might get equations that look like this. 3 times y minus 5 plus 25 equals 3y plus 10. Now here, I'm going to start as before. I will distribute to get rid of those parentheses. Just going to distribute here. 3y minus 15. Remember to distribute to everything inside the parentheses. Plus 25 equals 3y plus 10. I can combine the negative 15 and the 25, which gives me 3y plus 10 equals 3y plus 10. If I subtract 3y from both sides, I end up with 10 equals 10. And that actually is a true statement. So no matter what y is, y could be anything I want it to be. It can be any real number. It is always going to be true. We call this type of equation an identity, meaning both sides of the equation will be true no matter what. And the solution, we say, is all real numbers. Occasionally, we'll get an equation like this. Negative 5s minus 14 equals 2 times 2s plus 3 minus 9s. Well, again, distributing out, I get negative 5s minus 14 equals 4s plus 8 minus 9s. And then I'll get, combining some like terms, 5s minus 14 equals negative 5s plus 8. If I was to add 5s to both sides, I'd end up with negative 14 equals 8. But negative 14 can never equal 8. This is never a true statement. So because this is a negative true statement, there is no solution. Therefore, the solution is null, or sometimes we say the empty set. And we sometimes will write that as brackets that are empty, or we'll do a circle with a line through it. And that means empty set. Now, let's play around with some inequalities for a second. 4 times x minus 3 is greater than 6. So here we have the 4 times x minus 3, and again, wanting to get rid of the parentheses, so we're going to distribute the 4, and I get 4x minus 12 is greater than 6. And again, we need to get that x by itself, so we're undoing that plus 12, or the minus 12 by adding 12, so I get 4x is greater than 18. If I divide both sides by 4, I get x is greater than 9 halves. And I'm going to leave it in the fraction form because that's going to help me out later on. Let's take a look at this problem. Or actually, I want you to try this one. 5a minus 8 is greater than or equal to 4 times a minus 3. I want you to try this problem, so pause the recording, and then come back and let's see how you did. Alright, let's see how you did on this one. Done correctly, you would have distributed the 4 to the a minus 3 to give me 5a minus 8 is less than or equal to 4a minus 12. I want to get rid of one of the a's, so I'm going to subtract 4a from both sides. And again, nothing different than I've done with the equations. I'll get a minus 8 is greater than or equal to negative 12. I can now add 8 to both sides, and I get a is greater than or equal to negative 4. And so I know that my a is greater than or equal to negative 4. I think I will leave you with one more for tonight to try, and this is one that I will check with you in class to see how well you did. Negative 2 times k plus 1 is greater than negative 16 plus 5k. Let's see how well you do with this one, and I'll see you in class tomorrow.